Language models are a powerful tool for natural language processing tasks. To harness their full potential, it is crucial to understand both the pre-training and fine-tuning processes. In this video, we'll provide a beginner's guide to using these critical steps in the life cycle of a language model. We'll discuss the fundamentals of pre-training, the benefits of fine-tuning, and showcase practical examples to help you get started with fine-tuning large language models for various NLP tasks. So let's get started with understanding what is pre-training large language model. So basically, pre-training a large language model is a process of training a machine learning model on a large data set before using it to perform specific tasks. The idea is to train the model on a broad range of text data to give it a general understanding of language which can then be fine-tuned for specific tasks. To illustrate this, consider the example of a language model called BERT, or the bidirectional encoder representations from transformers. Now, BERT is pre-trained on a massive corpus of text which includes books, news articles, and Wikipedia. So during the pre-training process, BERT is trained to predict masked words or predict the next sentence in a given text. And this allows the model to learn the context and relations between the words in a sentence and across sentences. So once BERT is pre-trained, it can be fine-tuned for specific tasks such as question answering, sentiment analysis, or text classification. For example, if you want to build a chatbot that can answer questions, you would take the pre-trained BERT model and fine-tune it on a data set of questions and their corresponding answers. So during fine-tuning, the model is trained on a smaller task-specific data set to adapt its predictions to the specific task. Pre-training a large language model like BERT is computationally expensive process, but it allows the model to learn general language patterns and relations that can be applied to a wide range of tasks. And this makes fine-tuning more efficient and effective as the model has strong foundation of knowledge to build upon. So to understand this better, let's understand it using a Python code. Now we know pre-training a large language model requires sophisticated deep learning frameworks and significant computational resources. So in this example, we'll use the Hugging Face Transformers library, which provides access to pre-trained models and tools for fine-tuning. So to illustrate the concept of pre-training, we'll use a small synthetic data set to simulate the process. And please note that this example is for demonstration purpose only and is not meant to be a practical guide for pre-training a large language model. So for this, we'll first install the necessary libraries, then we'll create a synthetic data set. In this case, we'll use a simple sequence-to-sequence task where the model learns to predict the next word given the previous words in a sequence. Next, we will use the Roberta model, which is a BERT-like model from the Transformers library. We'll fine-tune a pre-trained Roberta model on the synthetic dataset. Please note that you'll need a GPU to run this example efficiently. In case you don't have access to GPU, you can still run the code, but training will be much slower. Then we have created a synthetic dataset and use the Roberta model for illustration purposes. In practice, you would use a much larger and more diverse dataset such as the book corpus or open web text corpus and choose an appropriate model for the task at hand. Next comes the fine-tuning large language model. Now this fine-tuning a large language model means adapting a pre-trained model to perform a specific task by training it on a smaller task-specific dataset. Here the idea is to leverage the general understanding of language that the pre-trained model has learned during pre-training and apply it to specific problem, making the model more accurate and specialized for the task. To illustrate this, let's continue with the example of BERT model. Now pre-training BERT on a large corpus of text gives it a broad understanding of language which can be used to perform various natural language processing tasks. To use BERT for a specific NLP task, you would fine-tune the pre-trained models on a smaller task-specific dataset. For example, let us say you want to build a sentiment analysis system that can classify the sentiments of given text as positive, negative, or neutral. So you would start with a pre-trained BERT model and fine-tune it on a data set of text with the label sentiments. So during fine-tuning, the model will learn to recognize patterns and features specific to sentiment analysis, such as the use of positive or negative words, sentence structure, and context. So fine-tuning a large language model requires less data and computational resources compared to pre-training, as the model already has strong foundation of knowledge. So fine-tuning can be thought of as adjusting the model's prediction to better fit the task at hand rather than learning everything from scratch. So to summarize this, we can say fine-tuning a large language model is a process of adapting a pre-trained model to perform a specific task by training it on the smaller task-specific dataset. And this allows you to leverage the general understanding of language learned during pre-training and improve the model's performance and the desired NLP task. Then let's understand it better using a Python code. Now we know that fine-tuning a large language model involves adapting a pre-trained model to perform a specific task by training it into a smaller task-specific dataset. So in this example, we'll use the Roberta model and the BERT for sequence classification model from the Hugging Face Transformers library, which is designed for sequence classification tasks. Here we will use a pre-trained Roberta model, that is a task-specific dataset, and a trainer class from the Transformers library to fine-tune the model for the multi-class classification. So first we will install the necessary libraries. Then we'll create a simple multi-class classification task. So in this example, we'll use the STSB dataset, which contains sentence pairs and the similarity score for each pair. Then we will define the training arguments, and such as the number of epochs, batch size, and learning rate. Then we will define the trainer. Finally, we will train the fine-tuned model using the trainer. So in this example, we use the Roberta model for sequence classification. So in practice, you would use an appropriate pre-trained models and task-specific dataset for your desired task. So please note that these codes are not meant to be complete solution for fine-tuning and pre-training a large language model, because fine-tuning and pre-training large language model requires significant computational resources, and the examples provided are for educational purposes only. Then comes the difference between the fine-tuning and pre-training large language models. So first difference is in the purpose. That is, pre-training is the process of training a large language model on a large diverse dataset to learn general language patterns and relations. The goal is to create a strong foundation of knowledge that can be applied to various NLP tasks, whereas fine-tuning is the process of adapting a pre-trained model to perform a specific task by training it on a smaller task-specific dataset. Then comes data requirement. The pre-training requires a large diverse dataset, often consisting of millions of text samples. Fine-tuning requires smaller task-specific dataset, which may be in the order of tens of thousands or less depending on the complexity of task. Then comes computational resources. Now, pre-training the large language model is computationally expensive and requires significant computing resources, including powerful GPUs and high-performance computing clusters. Fine-tuning a model is much less computationally demanding, as it builds upon the knowledge learned during pre-training and requires fewer training iterations. Then comes training approach. Now, pre-training involves training the model end-to-end on a large unsupervised dataset, where the model is typically trained using unsupervised and semi-supervised learning technique such as masked language modeling or next sentence prediction. So fine-tuning involves training the model on a task-specific dataset using supervised learning techniques such as classification or regression. Then comes transfer learning. Now, pre-training allows for transfer learning, which is the ability to apply the knowledge learned during pre-training to other tasks. Fine-tuning is a form of transfer learning, as it leverages the knowledge learned during pre-training to improve the model's performance on the specific task. Then comes model performance. Now, pre-training provides a strong foundation of the knowledge that can be leveraged during fine-tuning to achieve better performance on an NLP task. Fine-tuning allows the model to learn task-specific features and patterns that improve its accuracy and performance on the desired task. So to summarize this, we can say pre-training is the process of training the large language model on a large diverse dataset to learn general language patterns, while fine-tuning is the process of adapting a pre-trained model to perform a specific task by training it on a smaller task-specific dataset. Fine-tuning leverages the knowledge learned during pre-training to improve the model's performance on a desired task. Thank you.